Alright guys, today we're going to look at how to factor the difference of two squares. So we've spent pretty much all of the factoring portions of the chapter learning how to factor quadratic trinomials. This is where we start a series of lessons on, well, what the heck do I do if it's not a quadratic trinomial? Okay, so that's what we're going to try to figure out today. And when you have a difference of two squares, that's one place where you can actually continue factoring, even if it's not a quadratic trinomial. So here's what I want you to do. We've got four multiplication problems here. I want you to do a couple things. I want you to multiply each of these and simplify. I want you to kind of try to describe what did they look like originally and what did they look like after. See if there's a pattern we can use, and then we'll get into the rule. Okay, so take probably a few minutes, pause, and then come back. Okay, welcome back. I am not going to show all of the work here because at this point I'm assuming you can multiply two binomials. So if you messed up on something here, check your work with a friend or come see me if you're having lots of trouble here. So this one, after you simplified, you should have gotten x squared minus 4. This one, after you simplified, you should have gotten 9x squared minus 1. The next one down, you should have gotten 16x squared minus 9. And the last one, let's take a look there, you should have gotten 4x squared minus 25. Okay, so think about what you saw originally and what you saw after there. Okay, hopefully you've already thought about that, but if you haven't, you can pause and come back. But assuming you have, what did they all look like originally and after? Well, what hopefully you noticed is that it was the same binomial, except one had a plus and one had a minus in it, right? So we had 2x plus 5, 2x minus 5. Okay, and then after, we still had a binomial. Right? That's exactly what we had afterwards. Okay, so now if we're looking for a pattern that we could use here, when we did this, when we multiplied two of the same binomial together, except one with a plus and one with a minus here, we didn't end up with a middle term in any of them. We didn't end up with an x term. And now just try to think, well, where did the 16x squared and the minus 9 come from? Well, we know where that came from. If we were talking about this with FOIL, it would have come from the F and L portions of FOIL. That's where it would have come from. Okay, so I'm just going to skip the pattern that we can use part. Hopefully you wrote something ingenious down there. And I'm going to skip right ahead to the difference of squares rule. What we saw is the pattern that looked like this. If we do a plus b times a minus b, think for a second, what is our answer going to look like? Hopefully you were thinking a squared minus b squared, or a times a minus b times b. This is what we got going forward. That's not really what the difference of, well, I mean, it is the difference of squares rule, but usually we write it this way. We write it with the a squared minus b squared first, because that's what we're going to do now. We're going to start with something that's in this format, and we're going to convert it back into this format. Okay, this is more pattern recognition. Okay, we don't have like a special rule, process like splitting the middle term or anything like that here. Okay, so the whole idea is this. If you have two perfect squares that are being subtracted, you can take the square root of each, put them in with addition and subtraction and multiply them, and you're good to go. Okay, so here's what I want you to do now. I don't need you to jump right into the factoring part. If you feel like you can factor all four of these, go ahead. All I want you to do is circle the ones that are factorable, and by the ones that are not factorable, write the word prime. Okay, so that's giving you a hint. At least one is probably not factorable here. So again, circle the ones that you can think you can factor, and write prime by the rest. I'll give you a minute. Okay, Hopefully you've done that, or if not, pause if you need to. So the ones that are prime, b is prime, that's prime. Oops, I didn't mean to circle that. We're circling the ones we can factor. B is prime, and one more was prime. D was prime too. So now, D, I think it's pretty obvious why it was prime. This rule is called the difference of squares rule. Difference means subtraction. You need subtraction because the only way to get those x terms, that middle term to drop out, is when you're multiplying out is to have one positive and one negative that cancel each other out. But if you have one positive and one negative term, that means your last term is going to be -2. Okay, so that's got to be prime. The reason the other one is prime is because 3 is not a perfect square. Think about it this way. If you're going to have two of the same binomial being multiplied together to get this, what is that first term going to be? What two of the same thing could you multiply together to get 3x squared? Well, there's really nothing you can. Okay, so that one's not going to work. So here's how I like to tackle these. I like to first rewrite them just like the rule. Okay, so I'm going to write down kind of, again, what the rule is down here. A squared minus b squared equals a minus b, a plus b. So as soon as you can write it like that, oh, look, a is x and 1 is b. I replace all my a's with x and all my b's with 1. X minus 1, x plus 1. Oops, sorry, I forgot my plus. Okay, that's it. It's really that easy. And you can go back and check your work. See, if we multiply this out, we're going to get x squared minus 1x plus 1x. Those will cancel out. And then a minus 1 at the end. Beautiful. All right, now for a slightly trickier one. 4x squared minus 25. Here, the difference is we can easily rewrite this as 5 squared. But how do we rewrite 4x squared as something squared? Well, that's 2x squared. We want to multiply 2x times 2x. You see, that's why we needed that perfect square number there, because 2x times 2x will get us 4x squared. We need that perfect square first, too. And here, factors into 2x minus 5 times 2x plus 5. That's it for the difference of squares rule. Pretty easy rule. The biggest thing to keep in mind is that just having a squared doesn't mean you can factor it. Got to have subtraction, and all the numbers that are involved need to be perfect squares as well. That's it for this one.